Welcome to today's lecture. Today we'll be covering Chapter 5 in the Basics of Web Hacking book, that is Broken Authentication and Path Traversal. So if you look at the table of contents and kind of where the syllabus, where the course is going, we've moved from, as far as web application hacking anyway, we've moved away from that recon and scanning phase, and now we're into actual exploitation, active exploitation. If you remember from one of the previous lectures, we talked about that there is a lot of different the attack surface of a web application is really large, and so we're just focusing on some of the most prevalent and some of the easiest ones, necessarily easy because we have a nice exploitable web application to work with. Keep in mind, this is just a small token, this is just a small portion of it. So today, broken authentication and session management. I'm obviously not providing slides. Our main resource here will be from the OWASP.org website. You can see I'm on the top 10 list for 2013. Okay, right here. And they have a session handy enough, broken authentication and session management. So this lays out some of the, what are the agents, what's the vectors, exploitability is pretty average, security weakness, widespread prevalence, so obviously anything here that's being identified in red is identified as, pretty big. The impact is severe, and I want to show you a little demo here on why that is so severe. And it affects everybody. Okay, anybody that has a web application, you could be affected by this. And we talked about, when we started kind of the intro to the semester, we looked at that client server architecture, right? Our browsers are the client, the servers are the servers, and our clients interact with the server. We submit information, we query information, we get information, the server returns it to us in the form of HTML, our browsers mark it up, and we have then that application field, that interactivity. HTTP, the web, was never designed to be secure, and it was never designed to be stateful. Stateful meaning that I'm interacting with a web server as an actual individual, that it maintains that session, it maintains that state of what I'm doing, that I can go to Amazon and have a unique shopping experience. And so, as the author points out in the chapter, we've done a lot to try to bolt on and add this security and statefulness and authentication and access control and everything through the use of the session. When we looked at the sessions then, you saw that the session typically was generated from the server and it was sent back to your browser and stored as a cookie. Okay, and so therein lies the problem, in that there's just a couple of things we have to look at. One, again, the book talks about it a lot, is how are those session identifiers generated? That value that you get stored in your browser, how is that generated? Because if I can predict how your server is generating your sessions, then I can predict future sessions and try to hijack those sessions. If you don't protect that cookie very well in the application, there are certain vulnerabilities that we can piggyback off of, something like cross-site scripting. Cross-site scripting relies on the ability to inject JavaScript into a program. That JavaScript has the ability to access cookies. So if I can inject JavaScript into an application that then you execute in your browser, and it steals your session cookie and sends it to me, I have the potential to steal your session and then masquerade as you, as that user. So sessions are a very critical component, and how we identify our users and provide them with that unique value is very critical. Session generation then, typically when you look at these applications, you're typically working with PHP, so anything with a .php extension. That's a very popular, very common open source language for developing web applications. .NET's another one, so Microsoft's product, and those are a little bit harder to tell sometimes if you're looking at that site, but .aspx or .asp, those file extensions are usually indicative that you're looking at, you're working with a .NET application. Those frameworks and a lot of other frameworks that are out there, they provide their own session generation. That is, they determine how to provide you with that unique value and ensure that it's unique across every single user, and that and more critical component, that a bad guy can't guess the next value that server is going to generate. So with that, whether you're writing code yourself or you're working on teams where you're applying or using products, you have a team of in-house developers, you're purchasing code from a third party, you need to be able to understand and audit essentially their session generation and make sure that you're not susceptible to anything. A page like this, the OWASP page, is a great place to start. Bottom line is these frameworks that have their own generation, their session generation algorithms, use those. There are people that are dedicated full time that are very smart, that develop those systems. So use them. Don't try to do your own, because that is very difficult. That the same with cryptography. Cryptography, if you haven't studied it yet, it's a very complicated, very mathematical subject. And if you're not good at that, odds are you're probably not going to be able to create your own cryptographic algorithm that'll be worth a hoot. So use cryptography that has already been developed. Don't try to create your own process. There's just certain things you don't want to create your own. Session generation is one of them for sure, and so is cryptography. So how do we prevent it? Well, there's a lot of good resources there. Again, we're not really getting into we don't want to get into the weeds of the programming. A site like this is a little more geared towards the programmer side, but as someone who may not be a programmer, who's getting into the security field, it's still important to have a basic understanding here, because look at, here's one of the vulnerabilities. Am I vulnerable to broken authentication and session management? If you go through these lists, these are just some things that you should be able to look for. And as a non-programmer, you should be able to look through some of this stuff and identify it in the application and say, "Whoa, we got to stop here and further study or analyze what this application is doing." One of those, session ID is exposed in the URL. Okay, that's a bad place to put it. You want it as part as the form data sent as a cookie. And so what does that mean? That just means if you see sesh ID or SID or something in the URL up in this portion of your browser, then something's wrong. If I had something like this, or this is a very common way for PHP to do it, this is bad, right? So there's some easy things we can do to identify that it's there and then help work with whoever we're working with, whether it's yourself, whether it's your team, whether it's a third-party contractor, whether it's a client, to mitigate these things. So that's a little about session management. I'm going to show you guys a little bit of a demo here and how this demo is going to work. Okay, I'm going to pick on D2L just a little bit, and this can happen pretty much with any website. I'm not condoning that you do anything like this. Okay, that's why we have the VMs and the DVWA app. Okay, so what I'm going to do, we're going to have two browsers. I have two browsers open. All right, that's Chrome, and this is my Firefox browser. So if I go back to in Firefox and D2L, you can see that I'm logged in. You can see my profile, it's identified me, here's my username, and that's good. So that means I went to the login form, I submitted a username and a password, it authenticated me, sent back my cookie, and now I have a session that's associated with authenticated session. So they got back a session and it's authenticated so that the application can identify me based off of that. If I go to Chrome, you can see that not only have I logged out, okay, but I can't log in. And if you look at my URL bar, you can see I've been to other pages before. So here's the URL for our home page for 250. Well, I think it's ours. It might not be. But clicking on it, and it redirects me back to this home page, right back to the login page. I'm not authenticated. Okay, two different browsers, two different sessions, two different cookie stores. They're separate. As far as web applications are concerned, they're separate. They may be the same people. Eventually, ultimately, when I try to authenticate based off of my username and password, it may come from the same IP address, but the browsers get different cookies, different session IDs. All right. You don't have to be able to do any of this. Okay, this is just for demo purposes. So don't worry about being able to edit your cookies here. I have for both Firefox and for Chrome. I have additional tools that I had to install, additional plugins or extensions in order to edit the cookies. So if you're interested in that, you can find those tools out there. Just do a search for them, and you can install them and work with them. But you don't need to. It's not required for the lab or any portion of the course. So this is just for demo. All right, so look at the site. Again, we can also see I have no cookies. So if we go to this resource tab, hit F12 for developer tools. This is in Chrome. Click on resources, and you can see for d12.sdbor.edu, that's the domain right here, I have no cookies. If I go to Firefox, okay, hit F12, no, I take that back. I'm going to hit this cookie. So I have this cookie editor plugin that I've added, and you can see that for this domain, d12.sdbor.edu, I have two cookies. Okay, D2L session val and D2L secure session val. Okay, clicking on either one, I can see the name and I can see the content. So let's steal these cookies. Okay, this is something that can happen in an application. I'm going to contrive it because we're just going to copy one from the other, but it is possible that in an application, through some sort of a vulnerability, you could steal somebody else's cookies and then try to steal, essentially steal that session. So let's get the key name. Okay, so we're going from Firefox back to Chrome, and same thing here. I got a little cookie editor program, and we're going to add a cookie. Okay, so there's the name, and here is the content. The content is the value. Right, and then I'll click that checkbox. Okay, so now you can see right here, I've added that cookie. Well, let's add one more because I have 2 cookies with this authenticated session. So we'll grab the second one. D2L secure session val. And the content. All right, paste that in. Click check mark. All right, so I've added those 2 cookies. I can see in this cookie editor that I'm using that they're right there. I'll need to refresh this page in order to see them. And let's see if I can navigate to that home page. And look, there I am. Okay, separate browser, but because I took those cookies, I now have that other session. I now have that other user's session. That other user in this case happens to be me. So simply by stealing them, I'm now me. All right, and you could take these values, but don't worry. I'm going to log out, which will make these values, no longer null and void. So, okay, so it's a big deal, right? This is a pretty weak way overall to protect these authenticated sessions, and every website's going to do things a little bit differently. Okay, so D2L does it their own way. They have their own protections built in. Other websites will do it the other way. So I just wanted to show you that it can be pretty simple in order to steal a session. This is me, right? I'm in this browser and I am me. I can do everything that I can do under my account because it is my account. So when they say, log out of web applications, this is one of the reasons why. Because if this session, if I steal it and these never expire, I can come back here and be you anytime I want. So that's why they always encourage people to log out. You log out because you destroy these values, so that the next time, if these were stolen, they'd be no good. You could no longer use them. So once I log out here, and we go back to Firefox, get rid of that screen, and once we log out here, the next time I log in, that session now is done. Okay, as long as they implemented the logout functionality correctly, which that is another weakness in session management. They should have in that logout routine, in their logout code, they should have destroyed that session so that that is no longer any good. All right, we're not going to test it. We're not going to get into the weeds here and beat up on D2L. I just wanted to show you that demo. So with that, we'll take a look at the lab. So the lab will be similar to the other labs, and then I'm just looking for some screenshots. The lab is going to focus on 2 aspects from the chapter. And one is going to be brute forcing, looking to expose passwords through authentication controls, and then the other will be just path traversal. Okay, I'm going to move that down. Yeah. All right. So with the first one, starts on page 88, read through the book, and the goal is to get to a point where you're using the intruder feature of burp to send a bunch of results to the application, and you're trying to find passwords. Okay, you can see here, this is a screenshot. I'm looking for something similar. You'll have, once you fire off the attack, you'll start sending a bunch of requests to that application. And what you're looking for, you see this length value? Well, these 4900, 4900, those are all failed login attempts. Then all of a sudden we get a 4940. Something's changed, something's different, so the response is different. So if we queued in and looked at that response, we'd see that it was a login successful. Okay, and now we can identify those, 4942. We can identify those in the response from that attack and see that admin has a password. And we already know that. And Smithy has a password. So go through those steps in the program. in the book. We'll take a look at that here shortly, and I'll just walk you through a couple things I think you should know before you start to tackle that problem. For the second one, there is on page 100 path traversal attack. So go through those couple pages and figure out, following the book, the answers are right there, how to dump this password file, past WD. Okay, and you can actually see it's right there. So go through that just to get kind of get a feel for what it is. Do that, and then try to enumerate other files. But all I'm looking for is a screenshot similar to this. Okay, and that'll be the lab. So a relatively short one. However, this one, if you haven't done this before, this can take a little bit of time. So that's why that second part is a little bit easier. All right, so we'll get that saved. When we're looking at our application, okay, we have a couple things going here. We have Burp Suite up and running, and I'm just going to clean this, remove all these items here so that we have more or less a clean slate, and we'll go into our login page and we'll log in. All right, we had Burp running, we had Firefox configured to use Burp, use our web proxy. So if we go back to Burp Suite, you can see we've generated a bunch of requests from from that session. Now, the whole purpose of that first part of the lab is to try to brute force that login mechanism. And there are, if you go to the OWASP page, you can see a great place to start with mitigating some of these attacks. And one of those, why you typically see when you go to a website and it'll say, okay, you have, after 5 attempts, your account gets locked out. Well, that is a common defense for this type of activity. Because if you can just brute force login, you can create scripts and just send attempt after attempt after attempt, then that is one way to attack an application. So oftentimes they lock the account out. It becomes a balance then, as we talked about last week. It becomes a balance of, how do I ensure the security of my users, but also provide them availability? Because if I lock myself out of my account and I have no timely way to unlock my account, now I'm denied access to the resources that I need to do my job or whatever I'm up to. So, it's a balancing act, and in every company you need to go through every position and figure out how you want to handle it. So now that we've got some requests, okay, we're going to go into, and it's brute force. This is the form we want, okay? Everything you do in Burp, you need to have an authenticated session. Okay, we need to expose when you attack this page, and so your session needs to be authenticated. If you do something in here, and then you go into Burp, and you spend some time, and you get everything set up, and you kind of figure out what's going on, and you start your attack, and it doesn't do anything, or it doesn't do what you think it should be doing, you may have been logged out automatically. Your session may have expired. Most servers are going to time out their sessions automatically after 10 or 15 or 20 or 30 minutes, okay? So if that's the case, log back in and set your attack up again. So if you need to keep activity, just go in here every once in a while and browse around, right? That restarts the session timer. We want to capture a login attempt because that's what we're going to use to feed into Burp to start this attack. So you can just type in anything you want, and let's type in something that we know isn't going to work. So there was admin, when we know it's in fact admin password. We attempt to log in, and we see that we get the invalid username or password. Okay. This is another part of authentication management, is how much information did we leak, right? If I said right here, your password was incorrect, then that would imply that the username was correct. So I could use that information to enumerate a list of usernames, potentially. So every little bit, every little piece of information can leak can leak something out about our systems, about our users, about our data, and we need to be very careful about that. Anyway, so we have that. We try to log in, and if we look at this URL structure, we can see that we're on page vulnerabilities, brute, username equals admin, password equals admin, login equals login. Okay, so not only does this tell us the structure of the website, so where to look for this in our tree, but also that we have anything that comes after a question mark as a query string value, URL parameter, right? So we have all these values that are just appended to the query string and submitted. So everything's done through the query string. If we go back to Burp now, okay, we look for that, we follow that structure, vulnerabilities, brute, and there's that request. All right, from there it's pretty simple. We send it to Intruder. Intruder now becomes active. We go to the Intruder tab, and we have like 2 levels of tabs underneath that. Okay, this one was from a previous. All right, so I'm going to get rid of that so you guys don't get confused, or I don't get confused more likely. So we have our target. Shouldn't have to mess with that. We have our positions. All right, this is where things can get a little confusing. Everything that's surrounded by these, I typically see these used as subsections, but these little S signs, that indicates a place where we want to send our payload. Okay, for this particular example, all we're really looking for is the username and the password. So we need to get rid of these. All right, and now you're set up. All right, now you got these two positions. You choose the correct attack type. In this case, it's a cluster bomb. You can read about them in the book because the author outlines what the different types are for. Once you get this set up, now you go to your payloads. Okay, and I'll leave that up to you to figure out how to get the payloads. Once the payloads are done, the last thing I want to point out, because it's not necessarily obvious, up here, Intruder menu, start attack. That'll start the attack, and that'll generate a screen. A window similar to that screenshot that I showed you in the lab, or that I provided in the lab document. For these payloads, you're going to figure out and feed in a list. And so there's two lists that you need to have created. Okay, let's move some stuff around. One, I just called dvwa_users.txt. That's this file right here. And where did you get this information from? Well, from part of your recon phase, part of your exploitation phase, in the last lab, you were able to dump all this information. So that's where this came from. You didn't just arbitrarily come up with this. You didn't get this because you knew this about the application. You got this because of previous activity. The other thing you need is a password list. Okay, and there's two places that you can get this. One is if you have the ability to connect your machine, your backtrack machine, to the internet, then you can do that. You can go to the website provided by the author, and you'll find some password lists. Okay, a little far there. And there's a bunch of password lists. There's some leaked passwords, but here is the 500 worst passwords. Okay, so you want to use a pretty short list, and that's the one that the author recommends. And I know it works with the lab, so you could download that and just follow the commands in the book to get that extracted. Put that in a location that you can find it. Okay, so I have mine on my desktop, and then you can feed that into Burp, set up your attack, and you're good to go. This is what it looks like. There's some graphic ones here, so if you're reading through that, just don't be surprised. The other one you can use is if you cannot connect to the internet. So I didn't get this password list uploaded to the iLab. The iLab is not connected to the internet, and you're kind of stuck with that machine as it is now. So if you can't get it connected to the internet, well, John the Ripper, because in the last lab we did some password cracking, it has a list of passwords. So if you navigate to pentest passwords John, do an ls, you can see, let's see here, password.list. Okay, we'll do a tail on that, password.list, and you can see, okay, it's a bunch of passwords. So what you could do is you could copy that to that same location, use it in Burp, and now you have a password list. Okay, here is that list. It's just a little bit longer, so your attack might take a little bit longer as it runs through all of these. And you might want to delete all these comments as well. Okay, so it's up to you. Use either one, use your own, find your own. Either way, the passwords in DVWA are pretty easy, so this isn't, you don't need a comprehensive list. The last thing I just want to point out, and we've talked about this now, the last part of the chapter talks about web application structure, and in one of the previous lectures we talked about, we looked at WordPress and Drupal and how our web application is structured. If you're going after a web application, especially a framework that you know it's Drupal, you know it's WordPress, you know it's some popular platform, you want to study that and understand how it works. When you look at a normal Linux file server or web server, how they're normally structured is you have var www directories. Okay, then inside here lives the websites. You can have one website, you can have multiple websites. It all depends on how you want to set it up. So navigating to this directory, we have the ability to look at all of these different files, and in this case, this is just our DVWA, and we can explore that. So when you find something like a path traversal vulnerability, you can exploit that to look around the operating system. With that, it helps to understand something about the operating system as well. Where does all the good stuff live? If you go to etc, and let's do a tail on passwd. Okay, that's the file I'm looking for you to dump. And you can see, what does this do? Well, it just gives us some information on users. Right? There's not a password in here. There's something called a shadow file in Linux. But this gives us some information. If I wanted to crack passwords, I'd need to dump that shadow file. Okay, and this would be a part of doing that. Okay, so here you can see all of those match up with what we're looking at above. So it's just, again, it's just important to, if this is all new to you, to spend some time and just navigate around Linux because it's very common. A lot of systems are based off of some flavor of Linux. Mac is based off of a flavor of Linux. So if you have a Mac, browse around there. Browse around different software and just get a feel for how this stuff is structured, because you have to understand how it's structured in order to just understand how to protect against it. So hopefully that helps. If you guys have any questions, please let me know. And that's it for the lecture today. All right.